Hello everyone, and welcome to Lab Manager's Tech Trends webinar series. My name is Trevor Henderson, Technology Editor for Lab Manager, and I will be moderating today's discussion, which focuses on forensic science tools and technology. Today we are fortunate to be joined by 4 leading industry specialists who will discuss some of the latest trends in forensic analysis and instrumentation. We like our webinars to be very interactive, so we encourage you to send us your questions at any point during the webinar, and the panelists will address these during the question and answer session following the presentations. To ask a question, simply type your query into the question box, which is located at the bottom left-hand side of your screen. We'll try to address as many questions as possible during the question and answer session, and if we happen to run out of time, I will forward any unanswered questions to the panelists and they can respond to you directly. Additional resources can be accessed through the document icon located at the bottom of your screen, and you may also move or resize any of the windows simply by grabbing them at the top or stretching them at the bottom right corner. At this time, you may need to move or minimize some of the open windows to see the live view. This webinar recording will be available early next week on Lab Manager's website, and at the end of this webinar, we'll share that link with you, as well as the contact information for all of our panelists. Today, we are fortunate to be joined by Dr. Thomas Tague, who joins us from Bruker Corporation. Dr. Tague is the Applications Manager for Bruker Corporation. Tom is also a member of the Visiting Scientist Committee of the Metropolitan Museum of Art and the Board of Corporators of the Worcester Art Museum. Tom received his PhD from the University of Utah in Chemistry and his Bachelor of Science from the University of Texas at San Antonio. He is a member of the American Chemical Society, the American Physical Society, the Optical Society of America, and the Microscopy Society of America. Tom has more than 60 peer-reviewed publications and 5 U.S. patents. Thank you for joining us today, Tom.
Thank you. Well, I'm glad to be able to talk with you a little bit about using vibrational spectroscopy for examining forensics evidence. So one of the first questions that comes to mind when discussing forensics analysis is which tool works best, which means you need high sensitivity and high specificity. There are many tools at your disposal in a typical forensics lab. Which tool is best? And for my opinion, you have to look at the evidence and say, do I need a high level of specificity or do I need that high level of sensitivity? If you need specificity where you want to identify an unknown, then vibrational spectroscopy is far and away the most specific tool available for identifying unknowns. It also has been around a while, so virtually every state hears evidence that has been examined by infrared or Raman analysis, so you're not going to have to convince a judge and jury of some new technique that might have some merit. So there are advantages there. People that are using spectroscopy right now are customs agents, police, Homeland Security. So you might see this in a very local environment or actually at the federal level. So examining trace evidence where you're looking at small microscopic particles such as fibers and maybe residual paint chips and other items works just great. And detecting and characterizing forgeries, counterfeit money, and so forth also works very well by vibrational spectroscopy. So the next item in looking at what type of materials you can look at, they kind of fall into a few different categories. The first is pharmaceuticals and drugs. This is obviously of high interest. In my state of New Hampshire, it's considered, heroin addiction is considered an epidemic, actually, and we've had a lot of deaths, and it may be the principal cause of death in our state right now, believe it or not, in such a rural state. So looking at, cocaine and other drugs is of really high importance right now. Also identifying organics or inorganics, being able to differentiate white powders, very easily done. Polymers and other such materials. Essentially any covalently bound molecule works very well by spectroscopic analysis. You could certainly look at some other things as well, but that's principally what vibrational spectroscopy works best as. And in the center, you see the fingerprint, and what that indicates is that every molecule has its own fingerprint signature in the infrared and Raman spectroscopy region. And so that is what makes the technique so specific and so desirable to use in a forensics environment. So you can certainly look at drugs, explosives, hazardous materials, and so forth, and with a very robust small spectrometer. You can use infrared or Raman that can go to the crime scene very nicely, quickly and easily. You can look at fibers, particles, paint chips, varnish tapes, documents, and so forth, as we talked about. You can see a Tonka mural down below. One of the biggest areas of forensics interest these days is looking at endowments at universities and other institutions, and a large percentage of these endowments are actually composed of forgeries that were made more than 100 years ago during that frenzy to collect art from around the world. So it is an active area. So when you look in the bulk material, and I'll kind of separate these examples from looking at the bulk materials to looking at microscopic samples. In this case, again, we're looking at heroin, cocaine, amphetamines, and of real interest in today's world are legal highs. So people going to nightclubs and not remembering what happened and when and so forth, and being able to react to new drugs, the new fashion of drugs that are being used for people to get high it's a really dynamic and fast-moving area of science, and one where spectroscopy can really be most useful. So who does the analysis? So you can do the analysis in a forensics lab where you bring the evidence back. You can do them in chemistry labs. You can also do them in the field. So at festivals, nightclubs, you can see Professor Measham there testing a drug at a nightclub in the UK. Again, these systems are intended to be extremely easy, highly mobile, and highly accurate in doing the identification of unknowns. So you can be an expert or a scientist such as myself, or you can be someone who might sit down literally and collect their first infrared spectrum and reliably be able to use it to obtain a good result. So this is the alpha spectrometer, and this is actually an important tool in the toolbox, a portable FTIR that it only weighs a few pounds, can be taken out to the field. You can test the white powder or whatever drug you might suspect as a drug or explosive agent or whatever. And these databases for doing the analysis now are very well developed. In this case, the drug identification using the Tic-Tac database of more than 26,000 drugs. These databases are accurate. They can also pick up, in this case, more than one component as shown by the image in the center, where you can identify the cutting agent and the active ingredient very quickly. So if you look at sensitivity, as I mentioned in my introduction, you could actually use something similar to an ion mobility spectrometer. Bruker sells a wide range of spectrometers. These are very nice for looking down in the nanogram region. But you can also look, in this example, at an unknown yellow paste and very nicely be able to pick up that it's a plastic explosive and type it, where you have 86% PETN and 14% of the plasticizer. And the results are very accurate in being able to do the identifications. For looking at microscopic samples, you can actually visualize, in this case, the object of interest. And here is a small fiber. And you can see that, not only do you want to use the bright field image shown on the left image, but also you could use polarized light that can give you information about microburrs and microfibers. And there are many forensics examples in the literature where looking at fibers has been important, and particularly doing infrared and visual microscopy on fibers has been immensely important. One of the most famous examples in the forensics world in the news over the last 15 years was the Princess Diana investigation, where a paint chip was recovered from one of the cars, and it was determined that from the paint chip analysis that there was not a third car involved in that accident that took her life. And this is a typical paint chip analysis where you can see the many different layers under microscopic analysis, then you can identify just by drawing the areas you want to have analyzed quickly in the software, and the resulting spectra are shown very quickly after a rapid analysis, and the binders, pigments, and additives can be analyzed quickly and easily. So to summarize the advantages of vibrational spectroscopy in this very short 10-minute presentation is, first, it's easy to learn, very easy to use. And so maybe historically it was a problem where you might figure you had to be an expert to be able to do an infrared or Raman analysis. That's just not true anymore. The competitive marketplace has dictated that things have become much easier and much more powerful in how they can be used by a very inexperienced user. Again, little to no sample preparation for infrared or Raman. It's very universally accepted, by having been in the area of scientific analysis for so long. Solids, liquids, and pastes can be analyzed quickly. There's no waste. It's very safe and very, very cost-effective. The expected lifetime of a decent FTIR or Raman system is on the order of 10 years. So again, after the initial investment, it's relatively inexpensive to move forward and do the analysis with very little operating expense. And with that, I'd like to thank you for your attention and turn the time back over to Trevor.
Well, thank you very much, Tom. And for our audience, thank you all for sending in your questions. I encourage you to continue to do this throughout the presentation. If you're joining us late, you can ask questions simply by typing your query into the question box, which is located at the bottom left-hand side of your screen. Our next speaker is Bernhard Wüst, who joins us from Agilent Technologies. Bernhard is a marketing and application development specialist focused on LC-MS and chemical markets with over 20 years industry experience. He has been working for Agilent Technologies since 1992 in a variety of roles and currently is Agilent's Global Marketing Manager for Sports Doping and Sports Medicine. Thank you for joining us today, Bernhard.
Thanks, Trevor. And with that, we already shoot along to the next slide. And so you can see where the idea of the application is coming from. I'm working, as said, already predominantly in anti-doping control, and there is the need for analyzing more and more polar compounds. And what you see here is basically the head of a poster that was presented at the TIAFT conference last year in Florence. And with this, we will later talk a little bit about the collaborators on one of the last slides. But let's go into SFC. For those of you who know SFC, not just from any sparkling water or something, you can have CO2 in different constitutions. So what we're looking for is here in that corner, above a certain pressure and above a certain temperature, where CO2 is in a supercritical state, and we use that state to use CO2 as one of our solvents in a chromatography. And if we take this a little bit more into details and we look into the solvent power of SFC and the viscosity that SFC has, then we can add basically multiple columns together to get up to 200,000 theoretical plates in a chromatography scenario. Together with different columns, you can analyze the very polar compounds. You can compare this with the proper column, almost with a Hilic separation. Move on to the next slide. The hardware is pretty well known since many, many years. There have been improvements in the back pressure regulator that you see here on the right side, and I will come back to this in a second. So if we look at the system, we have CO2, we have a pump, there is an injector, the column, and a diode array detector, and bringing into the stream from a second pump, that could be a binary pump, could also be a separate pump, is a modifier. And the modifier can be any solvent combined with water or buffer, anything that suits the analytes you are looking at. And if we move along, then we can connect this as well to a mass spectrometer. This is what I did. There is a splitter after the column that allows us to split a portion of the flow into the mass spectrometer. In order to help the ionization in the mass spec, we add another pump to it, which delivers a makeup flow. And that's also one of the beautinesses of that combination. You are completely free in the makeup to choose a makeup condition that enhances the ionization and therefore the sensitivity of the analytes you are looking at. So if we look more on the instrument itself, then you can see the pump for the CO2 and injector column compartment that's all integrated in that one system. Also the modifier pump is part of this stack. Then we have the splitter, and I hope you can see that picture a little bit on how this is actually just connected to the right side of the system. And an additional makeup pump that you can see here, which could be in an easy configuration, a simple isocratic pump. What you see on top in that little graph there is the instrument control. This is Mass Hunter, as this is running on a triple quad instrument, and you can see basically every single module that you see in any of those stacks being represented here, which means in a day-to-day routine operation, this is very easy going. Method has been set up, all aspects being stored and loaded together with the parameter file for the triple quad, so you get a seamless integration of the SFC into the Mass Hunter Mass Spec operating software. So if we look at the different analytes that you can run on an SFC, and then you can see here hydrocarbons, esters, amines, ketones from the left to the right, and the different modifiers that might help to push the compounds of the column. This is actually already also published in that reference that you can see here below. So moving on and looking at some polar drugs, norepinephrine, octopamine, oxylophrine, phenylephrine, tyramine, and on a C18 column in that case. And then you see already the trouble with these polar compounds is that they elute very early. And if you think now you also want to analyze metabolites that are getting even more polar than the parent compounds, then you will be in trouble, or you have to extend the chromatography on C18 for so long that your run times are extremely long in order to separate the very polar columns at the front. If we compare different column types, and then you can see with a C18 column, with a phenylhexyl column, which had a little bit of a different separation idea, and with a Hilic column that turns basically the chromatography around, so you can't see this, but the retention times are here in the 8 or 9 minutes, so we basically can see that the compounds are already started to separate. And if we look on this on an SFC, then you can see that this is well separated on an SFC. The first 3 pictures here have been basically reproduced based on a paper from the Doping Control Laboratory in Rome. And I used basically the SFC in a university in Berlin to get the SFC and the very same compounds to see how this compares. If we move along now and we look at octopamine and the different sulfates, this is a disulfate, a sulfate, and octopamine as the parent. And we look at this at reversed phase, at phenylhexyl, at Hilic, and at SFC. And then you can see that basically on Hilic and on SFC, the elution order is being turned around. Okay, so in order that gives you a little bit of an explanation on that this is kind of an orthogonal technique to the chromatography. If we look now at the method that we applied this to, so we had 7 stimulants, 26 sympathomimetics, beta blockers 17, and 1 analgesics that we had in the mixture. And you can see this is quite a range of log D values we covered in terms of to give you an idea from the very polar to the very non-polar compounds. And moving on to the method, looking at the system here, we inject, this is a fixed loop system. We inject 5 microliters diluted urine, 1 to 5 in THF. A column here which is called an ethyl-pyridine column that's been used for the application. Column temperature, and the rest is basically standard chromatography setup that you know from any of the analytical systems you are running. The Agilent mass spec here was run in electrospray positive and negative. That's been optimized separately from the chromatography in order to get the best precursor product ion combination for the particular compounds we've been analyzing. On the next slide here, you can see a cycle time of 15 minutes, which is giving you an idea on how quick that separation of these 44 compounds will give you. And this is actually, in fact, an overlay of many injections. And that's very different to old SFC systems you might know from 10, 15 years back, where retention time stability was not given. With the more modern systems, the back pressure regulation that has to do with partly the hardware, partly electronics that is faster, can do more decisions at the same time. That helps to keep the back pressure very stable in order to be able to use an application like this in routine. If I move on to the next slide, and there you can see we did a kind of correlation between C18, phenylhexyl, and Hilic columns and SFC. So you can see basically there is no correlation, which as a result says there is not something like you can take your reverse phase method and you can translate this very easily to SFC. There was quite some method development necessary to achieve this. The system can be enhanced with multiple valves in order to allow the automatic optimization of more than one modifier. So we actually connected like 10 modifiers. You can have 3 columns connected at the same time, which you can then also automatically change, and the same you could do with the makeup, which we had to do manually because it was an isocratic pump. If I move to the next slide to give you some results, and then it's an idea about the limit of identification, where for most of the compounds this is 2 nanogram MRPL that has to be analyzed like a threshold value, and for phenylephrine and octopamine, the levels are quite high, like 100 and 200. Even there, we are pretty much in the levels that we have to analyze. If we look into real life samples, and these are not synthesized metabolites, so this is really from an excretion urine, then you can see propranolol, and here you can see up to 4 hydroxy metabolites. This one we could identify because we had a reference compound, and you can also see that we get 2 sulfates where we can also identify this one because we did synthesize the sulfate in the laboratory and had a retention time reference for that particular sulfate. I'm moving to the next slide. As a summary, I'd like to mention SFC gives you a unique selectivity. It's orthogonal to HPLC. It can replace normal phase HPLC, which usually works with much longer cycle times, not necessarily the chromatography, but sometimes the optimization of the column for the next injection. It's complementary to LC or Hilic, which is the normal phase application, and we can cover a broad range of analytes, which also helps in doping control for the direct analysis of phase 2 metabolites. Sometimes this is very interesting to see, not only for research samples. Summary number 2, it is faster than LC most of the times, as we don't have to prolong the chromatography for the very polar compounds at the beginning. It is also called the green technique because we need much less solvent, as we are using CO2 for the majority of the LC column flow. It has the broad detector capability. We can also connect an electrospray interface, which was used, but also atmospheric pressure, chemical ionization for the more non-polar compounds, as this is needed. Then MS make-up gas could make-up flow, could be modified to increase the sensitivity, which is some sort of a next step we are planning to do. And you get even a stronger evidence for the sample identity using an orthogonal technique for the analysis. And last but not least, I'd like to mention the two gentlemen here from Chromsident that helped us with the method development in terms of the columns. Basically, the scientific backbone here is Professor Parr from the University of Berlin and Professor Botre from the Sapienza University in Rome, which is also the anti-doping laboratory in Rome, and a colleague of mine, Edgar Nägeler, who works out of Wahlbronn in Germany. With this, I'd like to hand back to Trevor. Thanks for your attention.
Well, thank you very much. And just a reminder that all of our panelists today have kindly provided us with additional resources, and these can be accessed via the document icon, which is located at the bottom of your screen. Our next speaker today is Matt Schwarz, who joined us on behalf of Labconco Corporation. Matt Schwarz, President and CEO of Schwarz Forensics, is a certified latent print examiner with an extensive background in law enforcement and serves on the Latent Print Certification Board for the International Association for Identification. This board oversees the certification process to become a certified latent print examiner. Matt is also a member of the newly created NIST Organization of Scientific Area Committee Subcommittee on Friction Ridge, and is the creator of the Schwarz Executive Biometric Identification System. Thank you for joining us today, Matt.
Thank you, Trevor, for the introduction. We're going to be talking about latent print development using silane acrylate, or also known as CA or superglue fuming. It's a very ease of use and cost-effective method that's used widely through law enforcement and forensic laboratories across the world. This technique can be used in the field or in the lab interchangeably. The issues with it, since it is such an ease of use and cost-effectiveness, is the consistency. Laboratories fail to tend to realize the mistakes or the errors built into the process used. And my slides aren't moving. Alrighty. So some of the things we need to keep in mind with CA processing is some of the pre-fuming tips, which involve the evidence handling. How do we handle the evidence? How do we package it? Steps taken before it enters the latent print processing system. A few of the bifurcated decisions that have to be made is if DNA or trace evidence is going to be collected prior to this type of processing. Also, another issue that causes the loss of information is drugs being packaged with the evidence that's going to be processed for latent prints later on. Separation of these types of evidence from the packaging early on in the process helps increase your success rate later on. A few of the parameters with CA processing that are consistent is air circulation. This is where a lot of the homemade fuming vessels or fish tanks or even garbage cans used out there tend to fail or break down in the process. Consistent, even air circulation throughout the whole fuming area helps ensure all the evidence within the container or the device is properly fumed. Another area that is pretty consistent is humidity. Throughout the world, depending on extreme geographical locations, usually 70 to 80% humidity during the fuming process is optimum for consistent latent print development on all types of evidence from semi-porous to non-porous types. A few of the things to keep in mind is age of evidence. If it's been sitting in a very dry, non-humid area for a long period of time, pre-humidity for that evidence might actually increase your success rates on the development of additional latent prints. A lot of the processes out there in the field right now do not have this option, or it's an option you have to always include with fuming. The biggest area of inconsistencies, I would say, with the cyanochromate processing or the CA fuming is when we get involved with actual superglue or CA used, the heat source, the amount of time, and the actual vessel you put the glue into or the glue tin. This process is a lot more, I'd equivalent it to manual photography. If you're familiar with manual photography, you're understanding if you take away some time, you make a larger aperture, you'll still have the same picture because it's the same amount of light's moving through, it's just in a different amount of time. With CA fuming, you have the same issues going on. First of all, we'll talk about cyanochromate, the viscosity of the glue. If the glue is runny in water, it'll volatilize very quickly in the process, accelerating the process. If the glue is thick, kind of like maple syrup, or just came out of the refrigerator and is cold, it's going to slow down the process, it's going to slow down the volatilization. Fuming time is going to affect this. Depending if the glue is consistent or not every time, you might have to add time or take away time. Then you have the temperature. We found in research and working on some different projects, heat sources from one to another are very inconsistent on their output. To be able to verify consistency in this temperature and the same increase in the temperature each time is very important for a consistent, repeatable result. And then something as simple as the glue tin. Just switching brands or switching sides will greatly affect the rate the process will occur. For example, if we have, think of it as a glass of water, and then another glass of water, and we take that second glass of water and dump it out over the surface of a hard, flat top surface. The one that's dumped out over the surface is going to evaporate first. The other one's going to be still full of water. Cyanochromate is the same process. If we're using a tin that's very small and we fill it deep with glue, and then we have another tin and we just put a little bit of glue so it just barely covers the surface area, and we put them on the same heat source, one is going to overfume the evidence. The other one's going to be very slow to fume, if it'll fume at all. If the glue is deep enough and the heat does not get through to the glue to the surface to where it actually volatilizes and starts the polymerization process, you will get no development. These inconsistencies in laboratories, these failure to be reproducible from one process to the next are avoidable with a solid, consistent, reliable, repeatable process. Another issue is the understanding of the amount of the glue you need, which is variable upon the size of the chamber you're using. But to establish that correct amount, so we're not using extra glue, which leads to other problems of overfuming or underfuming later on in this process, we recommend a process of measuring your glue prior to use during the performance checking, and then measuring the tin at the end. And we found the optimum amount of glue left over is around 10%. So if you take that remaining amount, divide it by the initial amount, you should be coming up with about 10% left over. This is important because that last 10% we find between particles or other material in the CA glue formula, it doesn't all volatilize. So you're always going to have some residue left over. And when you get to this final 10%, the time it takes to volatilize that remaining part off takes so much longer than the first 90%. It can add into overfuming and other issues. Another issue we like to look at is the exhaust. A lot of labs using, again, we'll go back to the fish tanks, or some use permanent boxes, different varying size boxes in the wall built into their latent print unit. Exhaust on these is sometimes less than perfect or consistent. When we're using an automated system, that the exhaust actually turns on and it doesn't require the end user to be standing there. They work good until they stop. And not knowing the proper amount of glue to put in your tin, the volume of your chamber, and how your exhaust works, this actually leads to overfuming and damaging of evidence. What happens is the technician or the examiner will be using an automated system. They'll put their glue in, they'll put their evidence in, they'll start the process, they'll get taken away for other duties and tasks. They know the system will stop, exhaust all the CA fumes, and then turn itself off, and they can return at a later time. What they don't realize a lot of times is that heat plate does not cool back to room temperature. It's still retaining the heat. The tin could have extra glue in it. It's going to start the volatilization process all over after the fuming has, or the exhaust has stopped. All the exhaust is doing is pulling off that CA fumes from the tin and putting them through the filter. But once the automated exhaust stops, those fumes start building back up in the chamber, and you see the evidence being overglued to the point where it can damage it. One of the new things on the market with the BT capture by Labconco is we actually built in a continual fume exhaust into the system to avoid this type of damage to evidence. The exhaust will continue until an operator intervenes, and after a certain time when it does shut off, there's a continual exhaust from day to day where you can set to run every 5 minutes on the hour or every 2 hours. Keep any glue residue or fumes from building up inside the chamber. The next biggest thing in the automated side of CA fuming is the actual automation itself. There's several different models out there, several different types that have an automation to a certain level. There's no way to calibrate them. There's no way to adjust the readings, and you're not sure if you're really seeing the end product. A lot of them don't give you the option for real-time temperature for your hot plate, and the humidity levels are maybe 5–10% at best. With automated, you need to be able to get inside and actually verify your built-in humidifier in your hot plate with a surface temperature or hydrometer. This is important also for the labs that are ISO 17025 and 20 for your performance checking for your evidence processing. With the BT capture, the new chamber by Labconco, you can actually go in and adjust these different variables so you have real output consistent with what your performance checks show. Other things we need to keep in mind is the actual size and dimensions of the fuming area. This measurement I consider one of the important ones when I'm looking at different units to compare for purchasing for end clients. What we're actually purchasing is the square footage of processing area. How usable is it? What's the shape and size? How many things can we fit in there? What's our options for shelves, racks? How can we place evidence evenly throughout so we have even, consistent air and fume flow, and also use the whole chamber for maximum efficiency? You have different types, different sizes, different brands. Some of the best ways to sort these out is to take that actual square footage and divide it into the cost of the unit so you can actually figure out what your cost is per square footage. Give you kind of a baseline to compare different types of systems. How many shelves, bracket holders, things of that do you have to allow you to move evidence throughout the system so you can maximize the different cycles? Some of these different accessories can mean huge things for efficiency and also keeping evidence organized and made it back to its parent item. This will help you keep better inventory and control over your samples. Another thing with the CA fuming process and your CA chambers is cleanliness. The cyanacrylate works with a polymerization onto this fingerprint surface. Once that polymerization starts, it will keep on building onto itself. So if you have fingerprints, things where you touch on the glass or the interior of the chamber, you'll start developing those before you'll start developing the fingerprints on the evidence. So it's important that you always work with a clean work area that's easy to clean and free of foreign material. And lastly, with CA is after we get the fingerprints fumed. There are several techniques to make them more visible with different dye stains, photography, ultraviolet or infrared types of photography. New on the market, and what we're seeing more and more, is the cyanacrylate glue that is infused with actual dye stain in it. There's a couple different brands in the market right now. We've had great success using them. I've tested several of the brands, and here's some results of some of our tests using the BT capture chamber. What we have found out, though, in our testing and the use of these different infused dye stain cyanacrylate formulas is they are very, very sensitive to temperature, humidity, and time. They're sensitive to the point that if you try to use these in a lot of the different automated chambers out there, which we've used several different brands, you will not get the same results. And a lot of times they won't even fluoresce at all. So you're spending a lot of money for an expensive product that saves you a lot of time and effort in additional steps of dye staining and evidence handling to get it all done at one step. But the equipment that's currently on the market, other than the BT capture, will not hit the parameters to make sure you have the consistent end product of cycle-to-cycle performance, which we found you need to make these work. So in closing, I'd like to thank you very much for letting me speak to you today, and I hope you found it helpful.
Well, thank you very much, Matt. Our next speaker and final speaker of the day joins us from Abbott Informatics. Dr. Robin Gall is the Senior Product Manager for the Forensic Team at Abbott Informatics. Abbott Informatics offers the StarLIMS lines of information management systems. Dr. Gall worked for the Broward Sheriff's Crime Lab in Fort Lauderdale, Florida from 1996 to 2010. As an analyst, she was responsible for trace evidence cases, including the analysis of fire debris from suspected arsons. She also managed at various times the trace evidence, firearms, drug chemistry, and question documents units. During her time with the lab, she also became a certified ISO 17025 technical assessor. In addition, she is an adjunct faculty member for the Nova Southeastern University and Broward College. Dr. Gall brings her forensic domain experience to her role as Senior Product Manager, and it is her responsibility to ensure the product. Thank you for joining us today.
Thank you, Trevor. Today I'm going to be talking about LIMS, Laboratory Information Management Systems. And as my co-presenters have shown us this morning, a laboratory generates a lot of information and a lot of data. And laboratories need a mechanism and an automated system and an electronic system to manage all of this data that's being generated. Now, there are a lot of these products out there on the market, so today what we'd like to discuss is what key features we can look for to increase the return on our investment. This investment that you're going to make when you purchase a laboratory information management system is one that you're going to have for probably 7 to 10 years. So you'll want to make sure that you choose a product that's going to fit the needs of your agency, not just today, but also into the future. Here at Abbott Informatics, we do offer a web-based solution, and a web-based solution is something that most agencies today are looking for out there. StarLims offers products for a wide range of industries, which you can look at on your own later. And today, as I mentioned, we'll be talking about forensics specifically. And we're going to be looking at what can we be looking for in a system so that it supports all of our forensic activities, be it the laboratory, property management, crime scene, etc. Certainly, there's a basic expectation that an agency would have of a LIMS system, and most of them out there will do these basic things, such as log in evidence, create a case, indicate what units of the laboratory need to test the evidence. Supervisors will be alerted to the fact that there's work that needs to be done, and they will assign the analyst to work on the case. The analyst will be retrieving the evidence. There will be chain of custody documentation. Analyses will be conducted, results entered, reports generated. Those reports will be reviewed and disseminated, and then ultimately that evidence will be returned either to a submitter or to a property unit and so forth. These are the most basic expectations. Now, ideally, if all of this is being done in your LIMS, you can really get away from a lot of the paper that's being generated today. Now, one of the things we want to think about is, the evidence is coming into the lab from somewhere, maybe crime scene, maybe just submitted from an office or a property room, and at the end, again, it's going to go back somewhere. So let's think about how many different systems do we need? Do we need a system? Do we need to buy separate systems for the lab, for the property unit, for the crime scene unit, and for our law enforcement agencies and the attorneys, prosecutors, etc., to log in and view that evidence? I would suggest that you want to look for a vendor who can actually provide you a more comprehensive system that offers all of these features. Anytime one has to interface two separate systems, even if they're two separate modules from the same company, those interfaces have to be maintained. And if you're dealing with different vendors, you're talking about multiple service contracts, etc. So you want to consider, is there a vendor that I can go with that can provide for more of my needs without having to do these separate modular interfaces? And then the other system that we need to consider on top of all of this is our quality system. Very important. That's the overreaching umbrella over everything that we do in forensics. Certainly, anyone working in a laboratory is aware that there are products out there on the market that can be purchased just to handle their quality assurance activities. I strongly believe that it's better if you can go with a product that integrates the quality as part of the core LIMS rather than a separate system. Your LIMS should actually be acting as your active partner in your quality assurance program. For example, document control. If I can upload my training manuals and my SOPs into my LIMS and link them to the analyses, if I have a new examiner working in a unit and either it's a new examiner or maybe we've changed a procedure, if the analyst needs to view that SOP, why go to a separate system? Instead, while they're there conducting the analysis, it would be great if they could just click a button and view that SOP already stored within the LIMS. Purchasing services and supplies, all of our inventory items. If we can have all of our lot numbers for reagents and chemicals right there within our LIMS, as we're conducting our analyses, we can simply use a barcode scanner and just scan the barcode of those reagents. That way, with everything linked together, down the road, if we're conducting a quality audit, then we find that there's a case that maybe had a problem we think is related to a certain reagent, then we can simply go look up that lot number of that reagent and see a list of every case, exhibit, and analyses that was used, because the first question the assessor is going to ask is, could other cases have been affected? Think of how much time it would take to do this manually, or if you have a totally separate system, it's just not going to be as efficient. Process improvement is also a very big, important part of our work in a laboratory. Things like conducting our quality audits, documenting incidents in an incident log, and actually going through the life cycle of corrective and preventative actions. Wouldn't it be nice if your LIMS provider could give you a mechanism to do all of that within your LIMS? So if there is an issue on a case, you can just link the corrective action directly to it. You can actually conduct your quality audits there within your LIMS. Everything's linked. Documenting your personnel's training records, what they're certified to utilize, and what equipment and analyses they can conduct. For example, if we do have an analyst that we've hired and maybe they haven't been certified to perform every analysis in the system, your LIMS should be able to limit them just to those things they've been certified to perform. Same thing with equipment. And then, of course, generating our examiner reports and our technical reviews. If all of that can be done electronically, it's a real value. We, for example, with our company, we have clients who are actually doing technical and admin review of cases from home on their days off. Sometimes that's overtime, or they're working 410s, or they have the option to work from home. Can be very valuable if you're an agency that has laboratories in multiple sites, rather than someone needing to drive to different agencies or different sites within the state. Maybe they can just log in this web-based system. Very important that you check that your vendor is ISO 9001, 2008 certified for the design, development, and implementation of laboratory information management systems. Laboratories, crime laboratories, are held to very high standards with ISO 17025. Make sure your vendor is also holding themselves to a very high standard. Another thing you'll want to look for is a vendor that can provide you flexibility without the need to write custom code for everything that you want to do. So in our terminology, we think of customizations as something done to the system that requires someone to write code, versus configuration, which simply means you're making some choices about how you want your LIMS to work in your business environment. There's a lot of advantages if you can use a vendor that provides a large degree of configuration versus customization. It's not uncommon that very complex agencies do need some custom work done, but it should be minimal, because in the future, if you are to take advantages of upgrades put out by your vendor, if you have a significantly customized system, you're not going to be able to easily take advantage of those upgrades without needing to pay for professional services to build those customizations back in. So definitely try to go with as much a configurable system as you possibly can. Another hot topic in the world of LIMS is scientific document or data management systems, a system that can take unstructured data and structure it for you. You would want to look for a provider who can give you that sort of service built into their product or as an add-on product, so that you don't have to go out and deal with a totally separate vendor if possible. Again, trying to keep everything with one vendor eliminates a lot of problems down the road. So what we mean by this, we all know that something like an Excel table is very structured. You have columns, rows, and the data is very organized. But what about pulling information from less structured things like PDF files and so forth? That's what an SDMS system can do for you. And it can allow you to search your data by keywords, metadata, free text. It can allow you to route documents through workflows with versioning and signing off and so forth. So that's another key feature to look for to get more return on your LIMS investment. And what about mobility? We all live today in a very mobile world. We all have our iPads or our cell phones and laptops. You should be looking for a vendor that's really moving in that direction and will be able to give you the ability to, for example, maybe you're a crime lab director and you're at dinner and you get a really important call. You have a police chief. There's a high-profile case. He needs to know the status of a case. Wouldn't it be great if you can just go to your phone, look up that information, see what the status of the case is, what units have access, what have been assigned, who's the current custodian, what's the status of the work in progress? Is there a final report that you could just click a button and email to him? Very, very useful to have some kind of device that you could do that and access all this information when you're off-site. User management. Maybe somebody's working and they get locked out of their account. Wouldn't it be great if someone can just go in and unlock that account, give them a new password? Chain of custody transactions, especially out in the field, maybe with a tablet or your iPhone, being able to conduct chain of custody transactions with username and password authentication right there from your mobile device. Or going in and doing a property audit. Maybe you want to audit Section A of your drug vault. Wouldn't it be great if you could just pull up a list of the evidence that should be there and just start scanning it with your phone. So these are some kind of things that you want to be looking for in a very forward-thinking way of where your agency wants to go around mobility. And will the technology of the vendor that you're going with let you even create your own apps? Maybe you don't want the ones that they have out of the box, or you want to modify them. That's a good thing to be asking about. And then another really big topic is big data. We have lots of data, and data is great, but it really isn't very useful unless you can turn it into actionable information. All this data that we're collecting, we want to be able to look at it in a way that helps us make informed decisions to make our operations run better, faster, smoother. So be thinking about, are there products out there and the vendors that you're looking at that can provide some sort of business intelligence tool as part of their LIMS solution? So maybe you're, as a lab director, you're asking yourself some questions about the efficiency of your operations. Maybe an analyst is wondering, am I meeting my turnaround times? There should be tools that your LIMS provider can give you to do that. So as an example, here's just one example. If I have maybe 5 different lab sites, as we see at the top with the sets of green and orange bars, maybe I want to know how many service requests am I receiving and rejecting across these different areas. So maybe I just want to focus first on the forensics lab. And these are different than CRISTA reports in that business intelligence tools will let you dig and drill into your data. If I just click on the forensics lab, my whole screen will refresh and show me just information about that. Now maybe I want to dig deeper into the rejected orange ones, that orange bar. Let me click on the orange bar and see my whole screen refresh. And now I'm going to be able to see maybe the reason for those rejections. Maybe I can identify a training issue. Okay, so that's the point of the business intelligence, is it's not static. You can look at your data in ways that make sense to you. Maybe it's a map of your state, maybe city by city. You can look at drug trends, et cetera. But if the data is in your system, you should be able to have these dashboards that let you analyze your data and make informed decisions. What partners is the vendors that you're considering working with? So if you're considering a given vendor, you want to ask yourself, who are their partners? Because if they're working with really reputable, leading, technology leaders out there in the field like Microsoft and Oracle, SQL, et cetera, then you can have some comfort that this is a good person to choose. This is a good company to choose as my partner for my LIMS because they have good partners working with them and supporting them. And finally, just a couple other things to think about. Is it a web-based system? Web-based systems are really the way everybody's going today because you don't want to have to go client by client, or I should say PC by PC, computer by computer, installing software. If it's web-based, you don't have to do that. Can they provide a kind of a client-vendor team approach to the implementation such that your team has better ownership of their product down the road and also can help you cut down on some of those professional services costs during the implementation? Incredibly important is that you look at how the product is licensed. You have to compare apples and apples and also try to get something like a 5-year cost of ownership. But in licensing, you want to ask your vendor, am I going to be paying per machine that I put the software on? Am I going to be paying per named user? Or am I going to be paying on a concurrent basis? For example, concurrent meaning that I might have 100 analysts in my laboratory, but if I only expect 50 people to be on the system at any one time, I may only need to buy 50 licenses. That would be concurrent. So definitely make sure you're comparing apples to apples. And is this vendor financially stable? As we mentioned, this is going to be a long-term investment. You will probably keep your LIMS anywhere from 7 to 10 years or longer. You want to make sure the company that you choose is going to be there to support you for the long run. And finally, do they have subject matter experts working with them, people who've worked in the forensic industry and understand and speak the same language that you do? That's also very important and really can go a long way to mitigating communication challenges when you have laboratory personnel trying to explain their requirements. Very helpful if the vendor has people who speak that language. So with that, I will end, and thank you for your time and joining us today.
Well, thank you very much, Robin, and I believe we will go directly into our question and answer session. While I have you, Robin, you mentioned that there's a trend towards web-based LIMS. Could you explain how your data is protected in a web-based LIMS system?
Yes, most of our clients choose to install the software on their own servers, which are behind a VPN, behind their firewall, and people from outside would VPN into that. Also, our system and most systems, I would say, would be role-based. So if you have a configurable system, you should be able to configure roles for the people who work in your laboratory such that they can only access those areas of the system that they should have access to. And the data should be encrypted both at rest and in transit. And you should be able to establish password rules, just like many of the companies we all deal with. We have to change our password on a regular basis. There's certain requirements around that password. All of those are examples of how you can secure your system in a web-based system.
Great, thank you. Tom, our next question is for you. How small can the particles be for trace analysis by FTIR?
You can get down to about 2 microns.
Excellent, thank you. And while I have you, how's the performance of IR or Raman when you're dealing with mixtures?
So usually, if you have a mixture of a few different components, you can use microscopy to try and collect an isolated spectrum of each component, but sometimes it's easier just to collect the overall spectrum and do a multi-component search, and then you'll get each component very nicely. So it just makes your job easier. Sure.
Bernhard, how easy is it to transfer LC or LCMS methods to SFC?
There is, as I presented, there is basically no direct correlation between LC and SFC. So building a method development system with multiple valves and multiple columns is the easiest way to move forward, but there is less hands-on, but still some time involved to run a lot of experiments to find out which gives you the optimum separation for the compounds you would like to analyze. Thanks, Trevor.
Thank you. And are there special columns required for SFC?
There are different columns on the market, and as far as I know, the only difference between SFC columns and as they are marketed as SFC columns is that they are filled without water. There is some applications where you don't like to have water in the column where this could be useful, but besides this, you can use basically every column that you can use for an LC separation also on an SFC system.
Thank you. Matt, do you think it's necessary to invest in an automated system when you can simply develop adequate prints in a fish tank?
Yes. And there's a difference between automated and fully automated. There's automated systems out there now, but the consistency from cycle to cycle is still not there because of the lack of reproducible temperature, time, and humidity in that system. If it's fully automated where you know you have a consistent, repeatable product each time with the protections built in for overdevelopment or your technician walking away from the system, you would probably pay for that system within the first year or two just on the efficiency of them being able to multitask and do other things and leave that alone. With a completely manual system like a fish tank or some kind of other tank that involves human involvement, you can introduce air, and number two, they have to sit there and babysit it the whole time until the process is completely done because it's a visual indicator of when that process is done when you're doing it that way.
Thank you. And what do you think is the best post-treatment technique for getting the best results?
Right now, with the testing that I've done with these CA, dye-infused CA solutions, if you have the ability and the consistency with your chamber to make them work, I find that they're absolutely the best because you eliminate the chemical handling, the additional applying of chemicals, water rinse, the hazardous waste involved with that, and the time and effort. Other than that, I've seen some great results with some of the new UV-IR capture systems of full spectral imaging and some white light photography.
Great, thank you. Now, Robin, what type of return should you expect from your investment, and how soon should you expect to start seeing a return?
Some of the returns you would expect to see would be increased efficiencies within your laboratory. In an electronic system, you should not need to rekey information. You should not have to be looking for lost paperwork and misfiled paperwork. The other thing that you're going to get an advantage on is less human error. If you have a LIMS system that you're interfacing to your analytical instrumentation and you're pulling those results into the LIMS, you don't have somebody sitting there keying in the numbers and possibly making a typographical error. It also can organize all of this data very nicely for you. As an example, we had a client who recently went through an assessment, and the assessors had complimented them on how organized everything was, and they credited their LIMS to having everything nicely organized. You don't have to go get binders from all over your laboratory and carry them to a conference room. And then how soon you would see that return on investment? Almost immediately, in that one of the first things we see is as you go to implement a LIMS and you have to start making some decisions, the people within the laboratory, the analysts and supervisors, start talking about their own processes. And there's a lot of discussion that they start getting a lot of harmony about how are we going to do things. Because now that it's going to be done in an electronic system, they kind of have to all get on the same page. So that's immediate. After that, it really depends on what's involved. Some clients take a phased approach. It also depends on how many units of the laboratory are going to be brought online. Are we going to be migrating data, interfacing instruments? How many resources are going to be available from the laboratory to assist with helping make decisions and help the vendor to move the project forward? So there's a lot of variables there. So that part's going to, again, vary. But very soon you would start seeing investments just in the fact that you're having those conversations. You'll get some return on that.
Great, thank you very much. Tom, perhaps we could go back to you. Can the chain of custody be maintained during FTIR microanalysis?
It can, but it's a little easier with Raman, because with Raman you can actually use the confocal mode to look through the chain of custody bag and do the analysis of the material of interest without having to break a chain of custody bag. So certainly if you're willing to take the drug out of the bag that might have been found, then you can do that by FTIR. But Raman might be the ideal analysis tool in that situation.
Great, thank you. And are FTIR and Raman analyses admissible in a court of law?
They are, and there have been many precedents that have been set where usually if you say you've used infrared or Raman spectroscopy, both the attorneys on both sides will recognize them as well-validated techniques. I usually would recommend that you would work in the GLP or good laboratory practice compliant mode when you're collecting and processing data, in which at that point the data files themselves cannot be altered or changed, which again holds up well in a court of law.
Great, thank you. Bernhard, I have another question for you. How long does a bottle of CO2 typically last?
Well, difficult to answer, as of course this depends on the number of analyzers you are doing. We've been basically running day and out experiments for like 3 months, and the bottle was still there. It actually shows the pressure of the bottle in the system as we are using the gas CO2 and we cool this down in the FSC module to liquefy that before it is used. You don't really see a change as the CO2 pressure drops down very dramatically. So what we do in the laboratory, which is very wisely, we take a second bottle of CO2 and don't store this outside, because outside it is in winter cold, in summer it's hot, so it needs to be equilibrated to the room temperature for best use. So we have a gas bottle cupboard in the next laboratory where we store an excess bottle of CO2, so we can change this very quickly. Yeah. Thank you.
Okay, thank you. Now, Matt, is it common to put a lot of evidence in the chamber for batch processing, or is it more common to process evidence one piece at a time?
A lot of that's agency specific, but I argue when we go into labs and help them with workflows and designing their systems to batch process. In latent print evidence, it's unique enough that you shouldn't be cross-contaminating it. If you did have a case where there's like items, you maybe separate those batches, but you can still include other cases within that. If the design of the chamber's effective and efficient, you'll have different shelves and different locations within that processing chamber to individualize different cases and items on those individual areas. So you can avoid any kind of cross-contamination issues.
Thank you. Now, Robin, are there any efforts to standardize instrument outputs to integrate with LIMS systems?
Most instruments are fairly standard in the way that they output data. We can work with a lot of file types, and so I'm not aware of any actual efforts ongoing, but most LIMS vendors are able to work with the file types that are put out by the instruments on the market today. A lot of times interfaces are done using things like web services and API and so forth.
Great, thank you. Well, I'd like to thank everybody for the discussion today. And this brings us to the end of today's webinar. If you have any further questions, please consider reaching out to the panelists directly, as they are the true experts in this field. Their contact information, as you can see, is available on the screen now. And just a reminder that today's webinar video will be available at the link you see on screen. On behalf of Lab Manager, I'd like to thank our panelists today for all the hard work they put into their presentations. And I'd like to thank our sponsors, Bruker Corporation, Agilent Technologies, Labconco, and Abbott Informatics for sponsoring this Tech Trends webinar. As well, I'd like to thank all of you for taking time out of your busy schedules to join us today. Please mark your calendar for our next Tech Trends webinar, which will focus on trends in microplate technology. This webinar will be taking place Thursday, May 19th from noon until 1:30 Eastern Daylight Time. For more information on this and all of our upcoming on-demand webinars, please visit our website at www.labmanager.com. We hope you can join us again next time. Thank you and have a great day.